What's up? This is solving two-step equations. Before we actually solve some two-step equations, what I have for you right here is two algebraic properties that will become your best friends through this. The first one is the definition of subtraction. And all the definition of subtraction is defining subtraction by using addition. So if I have something like a minus b, that can also be written as a plus the opposite of b. And I'm sure you've done that before, and it's not anything new. It's just something a lot of students don't take into account when they're working on this solving. So we can turn subtraction into addition. You might look at that and go, okay, that's great. Why would we want to do that? The reason we want to do that is because of this next guy here. Commutative property of addition. Commutative property of addition says if a plus b, if you have something like a plus b, that can be written as b plus a. It means the order of addition does not matter. Okay? Again, another one of those things that's like, duh, Goodman, I know that. But here's the thing. Coupled together, these will make some of our equations look a lot prettier. Okay, so without further ado, let's jump in solving two-step equations. I'll start simple. We have something like 2y minus 3 equals 5. Let's do that. Okay, so now that we do this, again, remember our lulls, we're going to show all our steps. We're going to vertically align our parentheses. We're going to do our three-step check, and we'll make sure we put our answer inside a set notation, set of brackets. So this time, however, when I approach this, I'm going to look at this and I'm going to go, all right, attached to y. What am I doing to y? Well, now there's two things attached to y. I have a 2 by multiplication and I have a 3 by subtraction. So my question is, well, how do I tear that apart? Well, here's the thing. We're going to follow our order of operations backwards. So as I go through my order of operations backwards, law says, do the addition and subtraction first. We want to undo addition or subtraction first. So I'm following my order of operations backwards, undo addition or subtraction first. We're going to get rid of this minus 3 by adding 3. What I do to one side, got to do to the other. So now I'm going to bring this stuff down. Nothing was done to 2y. We just bring him down. Minus 3 and plus 3, they are inverse operations, which mean they undo each other, and that goes away to nothing. Equal sign comes straight down. Remember that vertical alignment. 5 plus 3, of course, is 8. Now, at this point, I still have something attached to y. This is why it's called two steps. We have to do another step to solve this. So we're going to divide both sides by 2 because this 2 is attached by multiplication. To get rid of it, we would do the inverse operation. We're going to divide by 2. So my 2's, they go away. Y comes down, and that's going to equal 8 divided by 2 is 4. So once again, I have a solution. Once again, I'm going to do a three-step check. So I'm going to rewrite the initial equation, 2y minus 3 equals 5. I'm going to substitute in the value that I think it is. So there's that set of parentheses. So 2 times, we think it's 4. I'm going to use my purple there just so you can see I'm substituting that 4 in. Again, I can go straight to my calculator and I can punch this in. So if I decide to put this into my calculator instead of doing it in my head, which is absolutely fine with me, and of course, the calculator's doing the work. If I punch that in, I wind up getting 5. So that tells me that this is correct. I have 5 equals 5. I apologize. It looks like I'm going off screen a little bit. So instead of going over here, I'm going to write it over here. My solution is 5. There's my set brackets. Ooh, that one got a little ugly. Simple enough, right? Again, I'm sure a lot of you are like, oh, I could have done that in my head. Why do I got to show these steps? Well, here we go. Let's try one like this. Let's put up something like f over negative 3 minus 7 equals negative 10. Now I look at it, I'm like, okay, my variable divided by negative 3, then 7 taken away is going to give you negative 10. What's the answer to that? Now you're starting to see they're not all like mentally very easily to figure out. This is why we're working our way up to these. So once again, I take a look at this and I go, okay, what's being put together here? What's the math that's being assembled? Well, I'm taking that f and I'm dividing 3 and then I'm subtracting 7. So I want to tear that apart, so I will follow my order of operations backwards, which means we're going to tear apart any addition or subtraction first. There is some subtraction there. There is the minus 7. So I'm going to go ahead and add 7 to both sides. Excuse me again. I cannot control the bells. So now this f divided by -3, nothing happened to it. So all I'm doing is bringing it down. Minus 7 plus 7, well, that cancels out. Equal sign comes straight down. -10 plus 7 is -3. Now, still attached to this f is this -3. He's attached by division. That is a fraction bar or a division. So to get rid of that division, I'm going to multiply by -3. What I do to one side, I'm going to do to the other. And I'm going to come down. Dividing by -3, multiplying by -3, they're inverse operations. They undo each other, so they cancel out. F comes down, and that is going to equal -3 times -3, of course, is +9. Once again, I believe that I have a solution. I'm going to perform a 3-step check. I'm going to come up here so I don't get too far down. So I'm going to rewrite my initial problem. F divided by -3 minus 7 equals -10. I'm going to now substitute in what I think f is. I think f is 9. Anytime you substitute, you cannot go wrong by using parentheses. We think f is 9. I'll use the purple there to show I'm substituting that in. Once again, calculator or Desmos. I'm going to go ahead and type this in. I got 9 fraction divided by -3. If you don't have one of these, I highly recommend you get them because you can type it in exactly as you see it. And then I can press enter, and guess what? It equals -10. That means that I'm correct. -10 equals -10. Whoa. Equals -10. This checks out. My solution is 9. Easy peasy, right? Okay. Let's step it up a notch. All right, let's try this one next. Now, this is the one where I look at this and go, ooh, that one's not so obvious. I've got -18 equals 7 minus 5n. Yeah, that's not as pretty. Remember those two friends I showed you at the beginning of this video? I showed you that definition of subtraction and commutative property of addition. We're going to put those two to use here, and I think you'll find out that it makes it a lot better. So the first thing I'm going to do is going to be like, I don't like this 7 minus 5n. I prefer to see the variable first because that makes more sense to me. So what I'm going to do is I'm going to go, okay, that's no big deal. I'm going to do 2 steps here. First step is that I'm going to change this subtraction to addition and add the opposite. That is the definition of subtraction. The reason that's so good is because after I do that and I have addition over here, I can go ahead and make to my next step where I rearrange that order and make this -5n plus 7. I think the bulk of you will agree that that is a lot easier to work with than this. We could do it from here, and I may show that at some point, not right now. But for right now, I think it would be a good idea to get here. Less mistakes will happen. So now when I look at it, I go, okay, now I'm going to solve for n. So attached to it is a -5 by addition and a 7 attached by addition. -5 attached by multiplication, 7 attached by addition. This is what happens when your brain gets ahead of your mouth. So now I'm going to solve that by following my order of operations backwards. I'm going to get rid of that +7 by subtracting 7. I'm going to subtract 7. So if I take -18 and I subtract 7, I'm going to get -25. And that's going to equal -5, and this plus 7 minus 7, that cancels out. Last thing is to get rid of that -5 that's still attached to the end. Attach that by multiplication, so we're going to get rid of it by division. Get rid of it by division. -25 divided by -5, of course, is +5. And that's going to equal n. There it is. Multiplying by -5 and divided by -5 cancels out. Now, I'm going to perform my 3-step check. I want to verify that works. Original problems, -18 equals 7 minus 5n. I am going to substitute in what I think n is. Parentheses, never a bad idea. Putting in a 5. Then, well, I'm going to let my calculator do this. I'm going to let my calculator do the work here. I'm going to do 7 minus 5, parenthesis 5. Notice what happens when I do that. If you can see that, typed in it exactly as I saw it, and guess what? I got negative 18. That is what I wanted. That means this checks out, and my solution is 5. Easy peasy. Hopefully you find that fairly simple. I want to point out one other type, and then we'll wrap this video up. The other type would be a situation like this. Let's use h. H minus 3 divided by 2 equals, let's go with 3. Now, why am I throwing that in there? Well, it's a two-stepper. However, there's one small thing going on. So anytime you have this extended fraction bar, what it's meaning is that all of this h minus 3 here is being divided by 2. So what, right? Well, here's the thing. That means anytime something's attached to multiple something else's, that means it's attached to that group. And anytime we're talking about a group, and that's why we talk GEMMA instead of PEMDAS, that means there's technically a set of parentheses here, okay? I call them implied parentheses, simply because that division bar being extended is saying, yeah, all that stuff's being divided by 2. Yeah, you can also write that by saying the parentheses h minus 3 is being divided by 2. So I'm going to put those parentheses in there because I think it's a little easier to understand. Why do I care about that? Because now when I go to tear all this apart and I say, well, there's a 3 attached by subtraction and 2 attached by division, I got to get rid of those. But when I follow my order of operations backwards, keep in mind, I don't go into this grouping until last. So the first thing that I'm going to do here actually is going to get rid of this division of 2. Remember, we're following order of operations backwards. We're going to get rid of addition and subtraction, then multiplication, division, then exponents, then we go into parentheses. So as soon as I see that set of parentheses, I know that drops to the bottom of the list, okay? So I'm going to go ahead and get rid of this by first multiplying by 2, multiplying by 2. When I do that, I'm going to have that h minus 3, and that's a grouping, equals 6 over here, or multiplying by 2 and dividing by 2, inverse operations, they cancel each other out. So then I'm going to look at this and go, okay, now I can go inside the grouping. When the grouping is all that's left, I can go inside there. And then I would go back to my order of operations and follow them in that order again. Since there's only subtraction attached, and since that would be the first step, this one's pretty easy. I'm going to get rid of that minus 3 by adding 3 to both sides, adding 3. And I'm going to find out that I'm going to have h minus 3 plus 3 cancels out, and that equals 6 plus 3, which is 9. If the parentheses bother you, once you're down to just those, you can just erase them. You don't actually need them once you get down to just the grouping, okay? So I have h equals 9. At least that's what I think. I'm going to go ahead and verify by a 3-step check. So if I do that, my first original equation was h minus 3 over 2 equals 3. I'm going to substitute in what I think h is. Remember, I said parentheses are your friend here. We think h is 9. Once again, don't stress yourself out with this. Use your calculator or use Desmos. I think some of you are realizing it would probably be nice if you had a calculator by your side at all times instead of having to flip back and forth. So if you don't have one, get one if you can. So I went ahead and typed it in. I'll show you on the screen here. So I have that typed in exactly as I see it. If I lower my shoulder there, you'll see it. It looks the same. And of course, it came out to equal 3. That's telling me that 3 equals 3. That checks out. And guess what? This guy's correct. My solution is 9. So let me take a second here and discuss the cheat check. Don't write this down. Just watch. Let's suppose I'm going to make a mistake, and I'm going to make a mistake on purpose, okay? So what's happening is kids make a mistake. It happens. It's math class. I make more mistakes than you ever will. So they come along here like, oh, cool, I'm going to get rid of this. I'm going to subtract 3. I'm going to subtract 3. I'm going to wind up with h equals 3. That's a mistake. I'm not getting rid of that minus by subtraction. So this is an on-purpose mistake. So if I get that, then I come over here and I'm like, boom, I'm going to put a 3 in here. Now here's what's happening. Kids are not actually typing this in to verify. They're just going 3 equals 3, this checks out, and they say their solution is 3. And then I tell them all the time, I go, you cheated the check. And they go, no, I didn't. Well, I know you did. You couldn't have typed this in. It would have never worked out. The reason for the check is to verify that we're correct. If you notice, if I type this in, I think it should be obvious, but I will show you. Hold on, I made a little error there. If I put that in to my calculator, notice I got 0. It's not equal to 3. That means it's not correct, okay? So if you do this, I know you cheat check. Don't do that. What should happen here is you should go, oh, wait a minute. That's not true. I made a mistake somewhere. So then we go back over, check our work. Oh yeah, I should have been adding 3 here, adding 3. This should be 9, okay? That's the purpose of the check. Not just for more work, not just because Goodman's a jerk, simply because we want to make sure we got our answers right, okay? All right, hope that makes sense, and that is doing equations with 2 steps.